We're going to talk about solving a system of equations with elimination. And this elimination method, or sometimes it's called the addition method. This is where we're going to use a property of equality. And this property of equality is literally that, equal things are equal. As long as we add the same thing to both sides of an equation, we're valid. So say I've got a system of equations that I'm going to start with something fairly simple, like x plus y is equal to 10, and negative x plus y is equal to 4. Now, as long as I add the same thing to both sides, this system is going to remain, or the system will remain valid. Well, what I'm going to do is, if I think of this second equation, negative x plus y is equal to 4, as long as I add the same thing to both sides, the system remains valid. So what we can do is we're going to add the equations to eliminate a variable. And in this case, x plus a negative x is 0x. So these essentially eliminate. So bang, bang. Y plus y is going to be equal to 2y. Now it's important to remember that. You're adding the coefficients. A lot of folks will just forget and put a y down there. And then 10 plus 4 is going to be 14. So now I've actually eliminated one of my variables and I can solve this equation. I can solve something with one variable. So I'm going to divide both sides by 2, and I've got y is equal to 7. So I've got half of my solution right here. What we're then going to do, this is essentially our first step. The next thing that we're going to do is we're going to back substitute. That's a T. We're back substituting. We're basically going to take this y, or our 7 for y, and we're going to plug this back into one of our original equations. So we're going to plug in this solution into our original equation. So what's happening here is I'll go ahead and take this top equation with x plus y is equal to 10. I'm going to plug in my y equals 7, so I'll have x plus 7 equals our 10. I'll subtract 7 from both sides, and I've got x is equal to 3. So there's the other half of my solution. So the solution to my system is 3, 7. And we're done right there. I don't have to take this any further. I have already done this. If we want to, and just to let you know, it doesn't matter which of these two equations I plug this into. I could plug it into the top one, as we did right here, and we came up with x equals 3, or if I plugged it into the bottom one, I'd end up with the same answer. If I said, and that's actually a good way of checking your answers, is say, negative x plus, to plug it into my other equation and see what happens if I do that. Negative x plus 7 is equal to 4. If I subtracted 7 from both sides, I'd have negative x is equal to negative 3. I divide by negative 1. And sure enough, I'd end up with, x equals 3. So it doesn't matter if y is equal to 7, I've got x equals 3 on both of these equations. This is a way of, and doing this, plugging it into both of these, this is a way of checking your answer. Or I should say, this is the way that I check my answers. Now, not all of these are going to be this straightforward. I'm going to go through, I'm going to do about 3 or 4 different examples here. I'll do another one, I'm going to do another one kind of similar to this, and we'll show you what this is going to look like. So let's say we've got one where we've got, I like this one. Let's say I've got negative 2x plus, or actually, sorry, minus 4y is equal to 1. And I've got 2x, oh yes, plus 4y is equal to negative 1. Yeah, let's do this. Here, this is going to be interesting because, okay, I can add these two things. Negative 2x plus 2x is, oh, that's 0. Okay. Negative 4y plus 4y is 0. So all of these actually canceled out on this one side. 1 minus 1 is 0. If all of your variables eliminate, we're into one of our 2 special cases. So if all of our variables eliminate and we're left with a true statement, for example, 0 equals 0, then I have an infinite set of solutions. This is what this is. Remember, this was our dependent. This was our dependent case. Now, if we're left with something that's false, if we're left with a false statement, I'll give you that in just a second, false statement, then we have no solutions. No sol, which is, this is an inconsistent system. I can't, sorry, I'm inconsistent. ENT. So this can happen. So if I were to look at something and say I've got, say I had like a system that was, say, 3x minus 2y is equal to 1, and minus 3x plus 2y is equal to 1. 3x minus 3x is 0. Minus 2x plus 2y is 0. And 1 plus 1 is 2. 0 equals 2? No. This is a false statement. So this means that we would have no solutions. So already we've gone through being able to find something with a single solution, with an infinite set of solutions. So this one is a true statement. 0 does in fact equal itself. It is very self-similar. Or something that is false, where we've got no solutions. And so we've got basically all 3 cases that we have here. Our last, something else that we're going to run into, excuse me, something else that you're going to run into is some cases where before you even get started, you're going to need to do some work on your system. Say I've got something like 3x minus y is equal to 4, and 2x plus 2y is equal to 24. Well, if I were to add these, none of my variables will eliminate. I can't do that just yet. But what I can do is we can multiply one or both equations to get a common multiple as a coefficient. Oops, that's a little too high. There we go. Back on screen. So 3x minus y equals 4, 2x plus 2y equals 24. We're going to have to multiply one equation, and I'm going to take this top equation by 2. I'm going to say, let's take this 3x minus y equals 4. I'm going to I'll show you my preferred sort of method of working on these, 24. What I'm going to do is I'm going to take this top equation, and my goal here is to have, I've got, this one is minus y and a plus 2y. I want this to be a minus 2y. So I'm going to take this top equation, and I'm going to multiply by 2. And when I do that, I'll end up with 6x minus 2y is equal to 8. And now that bottom equation, not doing anything with it. That's going to stay 2x plus 2y is equal to 24. And now when I add these two equations, my y's are going to eliminate. 6x plus 2x is going to be 8x. 8 plus 24 is 32. So after we multiplied this equation by 2, and we're just looking for some common multiple of, like, in this case, 1 and 2, we were able to eliminate one of our variables. Now I'm going to divide both sides by 8. So I've got x is equal to 4. So we've got this one done. Now we can back substitute into either one of our original equations. I'm going to substitute it to the second equation here. So I've got, so I'm going to back substitute this into this one right here. So I've got 2x plus 2y equals 24. So I'll have 8 plus my 2y equals 24. I'm going to subtract 8 from both sides. So I've got 4, oh, whoops, sorry. I've got 2y is equal to, what's it going to be, 16? 4, yeah, 16. I divide both sides by 2, and I've got y is equal to 8. So my solution, is that right? Why do I feel like I did something weird here? Anyway, but yeah, our solution here is going to be 4, 8. And of course, I could, since I'm questioning myself, I should double check myself. I should check to see that this works. If I do 3 times that 4 minus my y is equal to 4. Since I'm just checking this, 3 times 4 is going to be 12 minus my y equals 4. Sure enough, if I subtract 12 from both sides, I'll have negative y is equal to negative 8 divided by negative 1. Y equals 8. So sure, so I just, because I wasn't 100% sure, I checked my answer, and sure enough, it does in fact work. All right, that's all the time I've got for right now, so I will see you in the next video.